Good day, guys. This is your Sir A. I'd like to share with you my knowledge in solving engineering problems, particularly electrical engineering problems. So, if you are struggling on this, want to know more about this, or even just want to watch these review tutorials, this is all for you. God bless. So, this time I'm going to introduce to you the Ohm's Law. Ohm's Law is very important in dealing electricity or in dealing electrical engineering problems. For the Ohm's Law, it simply states that the current, let's say, we're going to have this on a formula. The Ohm's Law simply states that the current or the electric current is directly proportional to the voltage between 2 points and inversely proportional to the value of the resistance to the path of the current or the resistance of the path of the current. So it has a formula, I is equal to V over R. So that's definitely the Ohm's Law. Let's take note of this. This is very important. Okay, for the Ohm's Law, I is equal to V over R, we're going to have the units. For the current, again, this is electric current, having a denotation of I and has a unit symbol, ampere, named after Andre Ampere. However, for the voltage, this is the voltage having a unit symbol of denotation symbol of V, or it also called as potential difference, having a unit symbol of or a unit value of volts. And for the resistance, yung nabanggit ko kanina, the formula, the resistance having a denotation symbol of R and a unit symbol of ohms, named after George Simon Ohm. Okay. Also, I'd like to introduce to you the reciprocal of the resistance. The reciprocal of the resistance is equal to the conductance or having a denotation symbol of G. Again, this is conductance. For the Ohm's Law, mahalagang bagay ang pagkuha ng resistance din. Let's say we are dealing with a certain connection. We have two connections or most commonly known connection. We have the series connection and for the parallel connection. For the series connection, let's take note of this. Let's say I have one resistor connected in series by another resistor, connected in series with another resistor, and so on. Whatever the number of resistances or resistors, my value of total resistance here is just additive. R1 plus R2 plus R3 plus and so on. However, for the current flowing on it, for the I total, that is all equal. I1 or I total is equal to I1, is equal to I2, is equal to I3, is equal to so on. And for the voltage total, that is the summation of each voltage drops. Okay, that's V1 plus V2 plus V3 plus and so on. And for the power, take note, for power, they are the same for the series and parallel. Power is just additive. P1 plus P2 plus P3 plus and so on. Again, for the resistance, that's ohms. For the current, that's ampere. For the voltage, that's volts. And for the power, that is watts. Okay, that is watts. For the parallel, let's say we have R1 here, R2, R3, and so on. For the R total, that is 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus and so on, Rn. And for the I total, that is just the summation of individual current flowing on each resistors. I1 plus I2 plus I3 plus In. And for the V total, they are the same. That's V1 plus V2, Vt is equal to V1 is equal to V2 is equal to V3 is equal to so on. And for the power total, as what I have said earlier, P total is just additive of individual losses or individual power of each resistances or each resistors. I'm going to give an example about this. So sa problem na to, meron tayong dalawang resistor na nakaparallel, which has a value of 10 ohms and 15 ohms respectively. This parallel connection is now series to another resistor which has a value of 5 ohms. And it is being connected by a battery which has a voltage value of 12 volts. We are asked to find for the value of the current and for the power of the circuit. So, upon getting the IT, in getting IT, we will be using the Ohm's law. So, VT over RT, we have VT which is equal to 12 volts. So, check for the voltage. However, for the resistance total, we will be getting first. So, R total is equal to, that will be parallel resistor first, that will be 10 ohm inverse plus 15 ohm inverse, that will be for the parallel connection, plus for the series 5. So, R total is equal to 11 ohms upon using calculator. So, putting 11 ohms here, we will be arriving for the value of the current which is equal to 1.0909 amperes. So, this will be our current. However, we can also have for the PT or the value of the power, that is equal to IT square RT. So, this is the formula for power, and that will be IT is 1.0909 square times RT is 11. So, upon using calculator, we can have power total which is equal to, so upon using calculator, we can have power total which is equal to 13.0908 watts. So, this will be for the value of power. I'm also going to introduce to you the voltage divider rule or the voltage divider principle. We have VDP or the voltage divider principle and the CDP which is current divider principle. The CDP, which is a current divider principle. For the VDP, we are going to get the individual or the voltage across the first resistance or the first resistor and the second resistor. That's V total times R1 over R1 plus R2. However, for the V2, that is V total R2 over R1 plus R2. For the current divider principle, that is simply, we're going to get the I1 which is equal to I total. If this is I1, this is R2 over R1 plus R2. However, for the I2, that's I total. If this is I2, this is R1 over R1 plus R2. So, VDP can be used if the certain circuit is series and CDP if it is parallel. I'm going to give example about Ohm's law, resistance in parallel and series, and also VDP and CDP theory or principles. Meron tayong circuit na mabubuo upon reading the problem. So, we have, syempre, meron tayong source. Meron the 15 ohm resistor na connected in parallel with the series combination of 8 ohms and 12 ohms. Na meron din daw drop na binigay or voltage drop across the 8 ohm resistor which is equal to 48 volts. And we are asked to find for the value of the total current in this case. So, paano natin gagawin yon? So, in this case, we can have the value of the I total. How? We can just first get the value of the current flowing in this branch. So, whatever the current flowing in the 8 ohm resistor will also be the current flowing in the 12 ohm resistor. So, we can get for the Ix, that is 48 over 8, and that is 6 amperes. So, upon getting the Ix, we can now solve for the I total using CDP. So, by using CDP, we can have Ix, which is equal to I total times, if this is Ix, that should be the resistor across it. So, that will be 15 over 15 plus series combination is 20. So, we have Ix, which is equal to 6, I total, and the value of this. So, we can have the value for the I total, which is equal to 14 amperes. So, that's how you are going to use the CDP or the current divider principle. So this time, I'm going to introduce to you on how we're going to name a resistor through its colors or by its color. So that is being called as the resistance or the resistor color coding. Okay, I'm going to give you a mnemonics on how you can memorize it easier. Okay, we have here an example of resistor. This is an example of resistor. We have several bands or several color coding or several color bands. We have the first band, the second band, the third band, and the fourth band. So for the first two bands, that is called as the digits or the significant figure. The first digit and the second digit. The third band is for the multiplier side. And for the last band, that is for the tolerance. Okay, so we have here the color coding for the colors black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver, and none if there is no color at all. Instead of memorizing it by colors, I'm going to give you mnemonics for it will become easier. So that is just bad. It has a mnemonics of bad boy, rape, R, young girl, but Violetta gave willingly. Gardy said no. So every initials of each words pertains to its colors or signifies to its colors. Okay, for the bad, that is black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver, and no color or none. So that's how you're going to memorize it. Again, it's bad boy rape our young girl, but Violetta gave willingly. Gardy said no. So I'm going to cite an example for you to be able to know or to think on how you're going to use this principle in naming the value of the resistance or a certain resistors. So for the resistance color coding, we are asked to find the color of a 0.47 ohms. So 0.47 ohm. What will be the color code of the resistor? So paano yun? So ideally, the resistor which has a value of 0.47 ohms. So 4 is the first digit. So that is yellow. 7 is the second digit. That is violet upon looking at our table. And then silver is or has a multiplier of times 10 to the negative 2. That is silver. So in this case, 47 times the negative 2 is also equal to 0.47 ohms. Therefore, the color coding of this resistor is yellow, violet, silver. So that's just simple as that. For the color coding, didecode nyo lang siya kung paano ang positioning ng bawat significant figure and multiplier. So, mapapansin nyo, wala siyang tolerance. Wala siyang ibinigay na tolerance. Therefore, hindi natin gagamitin yung last band na for tolerance.